Dear students, today we are going to talk about time complexity. This is our first course on data structure, and this is the first topic that we are going to discuss. And data structure course is basically designed for students who have already completed their programming language course, basic programming language course, preferably C language. So this course will help you understand the coding, and it will also help you to write efficient code in a small amount of time. Let's get into our first topic. Today's topic is time complexity, and these are the things I'm planning to talk about in the first half. So time complexity before, so these are the things I'm going to talk about. So these are the operations. As you can see, I have written down over here. So the first operation is called the assignment operation. Then we have comparison operation. There is a thing called mathematical operation. Then calling function, inside function operations. So these are the different sorts of operations we do inside a code, right? So what is an assignment operation? Can anybody tell? Assignment operation can be denoted like this. Let's say x is equal to 10, x equals to 10. So what we are basically doing is we are assigning this value to the variable x. So this is an assignment operation. Then comes comparison operation. What is a comparison operation? If we write down x greater than y, or let's say x less than y, so what is happening here? We are comparing two variables, right? We are comparing x with y, comparing x with y. So this is a comparison operation. Then we have this mathematical operation. It can be denoted with, let's say, x plus y, or it may be x minus y. These are different sorts of mathematical operations, right? Comparison, these are mathematical operations. Then we have calling function. So inside a code we might have to call a function, right? So it can be denoted like this: y is equal to f of x. So what we are doing here, we are calling a function. Which function? We are calling f of x through y. So this is a calling function. And we may have some inside operations as well. As we get along, we will see some examples of this one as well. So what I'm trying to tell is, so there is a complexity in each of this operation, right? When we perform an operation inside a coding problem, inside a code, when we write a code, C program, it may be written in C, it may be written in Java, or it may be written in other languages. So what I'm trying to tell you is, when we are performing an operation, a complexity will be associated with this operation, right? This complexity is denoted with big O. It is called big O. This complexity is denoted with big O. We pronounce this one as big O, and it is denoted as this one, O. That's O sign. So when we perform one assignment operation, the complexity of this one should be O1, right? So when we are performing a comparison operation like this comparison greater than operation, the complexity of this one should be big O of 1. The same goes for this mathematical operation as well, this plus and minus. Let's say we are taking this one. So when we are performing a mathematical operation, the complexity of this one should be O of 1, big O of 1. And when we are calling a function, right, the complexity of this one should be big O of 1. It is denoted like this, big O of 1. So now there is a question. So let's say if we perform, let's say, 5 operations, are we going to have O of 5, big O of 5 as our complexity. So this is the question that we are exposed to, right? You might be having the same question. So this question will be answered in the next problem that I am going to illustrate. So in this example, this is the example I was talking about previously. So in this coding problem, as you can see, so this is a basic programming, this is a basic coding problem where inside the main function we have two variables, those are n1 and n2, two variables n1 and n2, and there is one additional variable that is called addition. So instead of writing addition, I can also write result as well. So in total there are three variables, n1, n2 and n3. So in the next line, as you can see, I have denoted n1 equals to 1 and followed by n2 is equals to 2. So in this line, n1 is assigned with a value of 1, followed by n2 is also assigned with a value of 2. And in the next line, what I have done is I have added these two variables, and the result of that one is being stored in the addition variable. So in this line, as you can see, there is only one operation, that is, you can say this operation is nothing but an assignment operation. This is an assignment operation. So same goes for this one as well. Here n2 equals to 2 means it's an assignment. We are assigning a value to n2. So this is also an assignment operation. Then we have this addition equals to n1 plus n2. So here we have a addition operation, and here we have this assignment operation. So altogether there are four operations. We have in total there are four operations in this code. So now the question is, so what will be the time complexity of this one, of this code? Time complexity. So this thing we were talking about in our previous problem. So this is what we are talking about. So as we can see that there are four operations, the question is, should the time complexity of this be 4 or something else? So this is the question. So the answer to this question is no, the time complexity won't be 4. Time complexity is denoted with O, and time complexity of this full problem is 1, O of 1, or you can say order of 1. Why is that? It's because even if there are 4 operations, the time complexity will not be 4, because if you observe closely, number of operations are not depending on you can say n, right? Number of operations are not depending on the variable n. That's why, so it's a linear, there is a linear relationship. So even if the value of n becomes 100, or let's say it becomes 200, and if we write n2 is equal to 300, so whatever the value of n1 and n2 is, the number of operations will remain the same. And how many number of operations do we have here? Number of operations are 4. So as the number of operations are not depending on the value of n or numbers of n, we can say it's the order of this system or order of this problem is O of 1, right? So we will see another example in a while when we will get some more idea about this one. In this problem also we are trying to find out what? We're trying to find out result. Result of what? We have inside this main function, we have these two variables. These are the variables n and result. So if we observe carefully, we can see what we are trying to do is we are actually trying to find out the addition. We shouldn't say addition, we are trying to find out the result of this thing, this operation, right? So this is what, if we observe carefully, we can say it's a series, right? It's a series where some operations are being taking place. So how many operations are there? There are altogether there are 4 operations. What are they? We have this multiplication operation, then we have this addition operation, followed by this division operation. So these are all, we can say it's a mathematical operations, and multiplication, addition, division, these are all mathematical operations, and this value is being stored in the result. So here this equal to or equals to is an assignment operation. So altogether there are 4 operations. So if we observe carefully, we can see that here we will be having 4 operations. But now the question is, the number of operations, are they depending on the input value? What is the input value here? Input value is n. So are these operations depending on input value n? The answer is no, they are not depending. Number of operations are not depending on n. So even if the value of n is 100, 200, 300, whatever the value of n is, it is not affecting the number of operations. The number of operations will always remain the same, and that is 4. So in this case also, we can say the time complexity of this problem, is O of 1, or order of 1, big O of 1. So as the number of operations are not depending on the input value, we can directly say the time complexity of this one is big O of 1. So here comes another code. This code will give you the same result as the previous one, but it is written in a different way. Here we are using a for loop, but in the previous problem we were not using any kind of loop. We used a simple series. So if you observe carefully, you can see there is a for loop here, and there is a variable. We have initialized the 3 variables here. Those are I, n, and the result. These are the 3 variables. And if you observe carefully, the value of this result initially is 0, and inside this for loop we have this line, I equals to 1, I is less than or equal to n, and every time we are incrementing the value of I, right? One value is being incremented every time. So this loop will count till n. If we have a value of, let's say, n equals to 5, this loop will perform this looping 5 times, right? This for loop will operate 5 times. And inside this for loop, what's happening? We are adding the value. So initially, right, what's happening? Initially we have this value, the result, right? The result initially is, the value of this one is 0. So if we add up this value, so every time this I is being added with the result. So let's say if we have, let's take an example. Let's say if we have n value equals to 1, what will happen in that case? So I, initially the value of I is equals to 1, I less than or equal to 1, right? So inside this one, this thing will happen, right? Every time R will be R plus 1, right? In the first case, result, this value is 0 plus 1, that gives you 1. And second time, what will happen? in the second instant 2 will be added, then 3 will be added, then 4 will be added, and then 5 will be added, and so on. It will go like this, right? So as you can see over here, this result is actually depending on the value of n. If we have n is equal to 1, we will be having 1 number of loop, right? If we have n equal to 2, we will be having 2 number of loops. We will be having 2 loops, and inside this loop we are having, if you observe carefully, see this, we are having 2 operations, plus and equal, right? Plus and equal, 2 operations. So if we have n is equal to 1, number of operation is 2, right? Can we say that? If we have n is equal to 2, n equals to 2, in that case number of operations will be 4. If we have 3, number of operations will be how much? 6, right? And if we have 10, number of operations inside this for loop will be 20, and it goes like this. So can we say that the number of operations are depending on input value n? Can we say that? Yes, of course we can say that. And the relationship between this is n and this is number of operations, right? So the relationship, if we observe carefully, there is a, what kind of relationship do we have? Can you say that? If this, now in this program, as you can see, there are 2 for loops. The first one, here is the first for loop, and there is another for loop. So this thing is actually called a nested for loop, a loop within a loop, right? So what we are trying to do, we are trying to find out the time complexity of this program, time complexity of this full code, right? So this is what we are trying to figure out, time complexity of this program, right? And inside the main function we have this 4 variables, I, j, n and count. These are the 4 variables initialized inside the main function. Initially the value of count is 0, right? So and there are 2 for loops, as I have told you before, first one, second one, and inside this nested for loop we have this count, right? So this is the, you can say this is can we say this is our main operation? You can say this is the operation that is being performed by this code. So this is what we are trying to figure out, and this count is actually depending on these 2 for loops, right? If I say this count is actually depending on this n, is it the right thing to say? Yes, it's the right thing to say, because as you can see in the first for loop, I is less than n, and every time we are increasing the number I. In the second nested loop, we have initialized another variable, that is j, but j is also less than n, and every time we are increasing the value of j to 1. Like if we have 0 at the first place, in the next place we will be having 0 plus 1. So it goes like this, right? And I and j both are depending on n. So I would suggest you to write this code on a compiler. You can use any of the compilers as you wish. Code blocks is also okay, Turbo C you can use, or any other compiler is also fine. Okay, so what I'm trying to find out here is actually, is there any relationship between the input value is n, right? In this case our input value is n, and the operation that we are performing is the count operation, right? count operation that we are performing. So is there any relationship between this n and count? Is there any? So I would suggest you to write down this code on a compiler. I have already done this previously, so I will directly write down the final answer to this one, right? I'm not going to discuss all this. It's your duty to compile this one and find out the count values every time. I have already done it, so I'm writing down the answers over here. So if I write down 1, the value of count will be 1. When n is equal to 2, count value, the count will be providing us with a value of 4. When n is 3, it's 9. When n is user defined, right? N is given by the user. So when n is 4, it will be giving us how much? 16, right? What if we have a value of n is equal to 10? So we will be having 100 in the count section. So same goes for, let me write down this in this manner. So let's say if we have 100 as n, input value n, the count value will jump up to 10,000, right? So what we can conclude from this relationship, can we say the time complexity? So in our previous examples also, we saw that time complexity is actually depending on the input value. Here this count, or in other words we can say our operation is also depending on our input value, right? What kind of relationship do we have over here? Can we say time complexity of this code is actually big O of n square? If we write this down, will that be a right thing? Yes, it's the answer. Time complexity of this code should be big O of n square, because it's depending, the operation is depending on the input value, and there is a square, n square type of relationship, right? So some of you might be saying that when you provide n value is equal to 1, inside this nested for loops we are actually having two operations, this plus and assignment. So instead of thinking this one, instead of assuming these two operations, we can combine together and assume both this operation as individual one single operation, right? So we have done the same thing for other cases as well, right? So same has been written for all other cases. We have combined this addition and this assignment operation together as one, and then we have assumed this count as a single operation, and then we have figured out the relationship between this count operation and the input values, and finally we have figured out that the time complexity of this one should be big O of n square. So we will be seeing another example where we will discuss about this in more details. So now in this one, in this example, can you see any difference between this example and the previous one? Yes, there is a slight change. In this one, I have added this line, this third nested loop for k is equal to 0, k less than n, k plus plus. So in this one, this is another nested loop, right? So I have added another nested loop, another for loop here, right? And I have closed this bracket here as well. So this is the only difference between this one and the previous one. So can you tell me the time complexity of this problem, of this code? So is there any difference between this one and the previous one? Yes, obviously there will be a difference. And if we just compare without even calculating or without even running this code in our compiler, from our observation we can directly tell that time complexity of this one should be O n cube, right? If we don't understand this one, I would suggest you to do a thorough check of this one, put the values of n here and find out the number of counts, right? So as we have 3 nested loops, we will be having the count will vary from this one. If we don't understand this one, for example, for your simplicity, I can simplify this one a little bit. So if we have 1, the count will be how much? What will be the value of this one? It will be 1. This is our final answer. That's what we are interested. And if we have n is equal to 2, we'll be having 8. If we have 3, we'll be having 27, and so on. So if I would suggest you to run this code in your compiler, and you will be getting a count number final answer as this one. So from this we can say that the count operation is actually depending on the input value, and thus the time complexity of this code is big O n cube, right? So what will happen if we have another nested loop? If we implement, or if we write down another for loop inside this loop, we already have 3 nested loops. What happens when we have another nested loop here inside this one, on top of count and underneath this for loop? Is it possible to have this? So I would suggest, I will say that time complexity in most of the cases, it will not go above big O n cube. Or I can say, while you are doing a programming problem, at most we will be having 3 nested loops, not more than that. If you are having more than 3 nested loops, you can assume that there is a problem in your code, and you need to debug it, and you need to write down the code once again, and you need to check that one. So this graph actually tells us, shows us the time complexity. Across this x-axis we have this input, number of inputs, and across this horizontal axis we have time. And as you can see, we have different time complexities around this graph. So big O of 1, or order of 1, is a flat curve, right? It's a flat line. Then we have this big O of logarithm of n. Then we have this one, big O of square root of n. Then we have O of n followed by O of n square, O of n cube, and O of n to the power n. So you might be asking yourself, which one is the better one? So it actually depends on the growth rate, right? The less the growth rate, the better the performance, or better the time complexity is. So in this case, the graph shows us this one is the best in terms of time complexity. Then comes this one, this is in second position. Then we have square root of n followed by big O of n. Then we have big O of n square, big O of n cube, and after that we have big O of n to the power n. So the conclusion is, the less the growth rate, the higher the time complexity performance is, right? And you haven't seen this right till now, big O of logarithm n. So when we will be doing the binary search, I will try to discuss this one as well, so you will get some idea at that moment. But for the time being, this is the conclusion of this lecture. So I would suggest you to go through this lecture once again. If you have any doubt, feel free to let me know. And in the next lecture, we will again talk about time complexity, but we will give some more examples, different examples, and talk about some other topics as well. Till then, thank you. Decide if you're ever gonna